The integration of a lighting control system and an audio-visual system is the process of connecting the two, which allows for communication and control to be shared between them. The sharing of controls allows the lighting control system to trigger specific audio-visual functions, and the audio-visual system to trigger specific lighting control functions. An example would be that when a presentation button is pressed on the lighting control wall station, the lighting control would dim the lights, but also tell the audio-visual system to lower the projector screen and turn on the projector. Lighting control systems and audio-visual systems normally do not use the same control language. So this is why RS-232 communication is commonly used to bridge the communication gap and connect the two systems. RS-232 stands for Recommended Standard Number 232, and as the name suggests, it is a standardized communication protocol. RS-232 is used to send serial data in a point-to-point configuration. This means that one RS-232 device can only talk to one other RS-232 device. The serial data can be in different formats such as binary or hexadecimal, but commonly printable ASCII characters are used. This is anything which you can type on a keyboard. The ASCII characters are combined together in a string format. An example of an ASCII string would simply be the word hello. The strings are case, punctuation, and space sensitive. This means that hello in all caps is not the same as hello in all lowercase. Once the strings are created, they need to have a delimiter. The delimiter is used to tell the processor that the end of the string has been received and to process the data. Commonly, a carriage return is used, which is represented as the following. Adding the carriage return to our previous example would give us the word hello carriage return. This means that the receiving device would process the word hello. With the string and delimiter defined, the next part of RS-232 communication to consider is the format in which the data is being transmitted. The core components of the data formats are the baud rate, data bits, parity bits, and stop bits. We won't go into detail of what each component means, but it is critical that the two communicating RS-232 devices have the same data format. There are several different configuration options for the components, such as using a 19200 baud rate versus a 9600 baud rate. But most of the industry has defaulted to the format of 9600 baud, 8 data bits, no parity, and 1 stop bit. This is commonly referred to as 9600 8 none 1. So we have the strings established, the data format worked out, and now we actually need to connect the two systems. Different cabling and connectors can be used, but the most common connectors are DB9, RJ45, or RJ11. In the next video, we will cover some of the common issues associated with audio-visual system integration and how to solve them.